So my name is Rob Sherwood. I'm CTO at Big Switch Networks, and today I'm going to be talking about a really interesting, completely different feature for Big Monitoring Fabric, so much different that we actually end up presenting it separately. So this is our inline mode. So traditional Big Monitoring Fabric, what I've just been talking about now, is what we call out-of-band. It's a physically separate deployment. It does not involve production traffic. It only handles copies of traffic. This actually goes, as the name implies, inline. So if you imagine like a traditional DMZ, you've got some untrusted part of the network, probably the general internet. And as traffic comes north to south, you might cross a firewall, you might cross like an intrusion detection system, maybe you've got some web proxy stuff, and then you've got your internal data center network. There's a bunch of interesting properties around this that I think everybody's familiar with, which is to say, if one of these boxes goes down, that's bad. Obviously, you deploy these in twos of everything, and you have kind of these weird kind of consistent X patterns of you've got two ingress-egress network routers, you've got two sets of firewalls, and you've got weird kind of cross-hashing. Mucking around with anything here is generally considered dangerous, and you should not do it. You certainly shouldn't do it on a Friday night. This can be a very problematic part of the network to work with. Not to mention pretty expensive. What you can do with our inline version of Big Monitoring Fabric, and this is a completely different use case, but it's actually the same underlying technology, is actually hang a collection of our switches between the north and south points, and then hang the same services off on the side. And then using service chaining can say, now you go through these same devices. So you actually have, these switches are acting like a layer 1 policy-based router. It's a bump in the wire. It doesn't do TTL decrement. It doesn't handle broadcast. It just is a direct forward. What gets interesting here is now you can actually start chopping up your traffic. You're not forcing 100% of your traffic to go through the same service chain. You can say, well, maybe from north to south I want you to go through the sequence, but my firewall is getting a little bit overrun. So maybe from south to north I'm going to bypass a bunch of these things. Or you can say, you know what? If the firewall goes down, I want you to stop forwarding traffic. I want you to act like the same case here. If all the instances of the firewall, because we can load balance, go down, let's stop forwarding traffic like there's been a physical break in the network. But if all the intrusion prevention systems go down, maybe by security policy that's going to be okay, and we'll just bypass those. So it's now possible to selectively bypass services in this node. And I'll come back to a really interesting use case around that. You start getting things like, now you can actually mirror traffic to multiple pairs of firewalls. So maybe you've got, probably like everybody, you've got all sorts of vendors chasing after you. Vendors are the worst, by the way. And so maybe you'd like to run two pairs of firewall vendors in parallel, maybe one sort of like a test mode. That's easy to deploy here. This becomes almost like a DMZ service to get traffic through. Do people understand this? Does this make sense?
Yeah, that's cool.
I love this idea. The security guys and say, we need physical separation and so on. Did you have some testing that your fabric cannot break, cannot be compromised, that is never possible to get traffic from untrust to trust? Yeah.
Yes, I mean it's one of these things where understanding how the Broadcom chip works and understanding like this. So essentially, this is using the same policy-based routes that the security guys already use. So you just tell them, okay, if you're okay with policy-based route level, like ACL level isolation, this is the same part of the chip.
The word I come from, they make physical separated networks, yeah?
That also depends on what the service is. So maybe in those worlds, you don't put the firewall here, but you still put the intrusion prevention, you still put the web proxy, you still put some other things here. And so it depends on the layer of security. That's more of what I think of as an auditing problem, rather than an actual security problem. It's just a matter of actually training the auditors that to understand how these things work.
I reminded of something that Ferro here wrote a while back about OpenFlow. It was a use case for OpenFlow with, if you're migrating from one pair of firewalls to another, in that case, putting OpenFlow switches either side of a firewall to migrate literally flow by flow, right? Symmetrically migrate inside and outside. You can direct one new flow through the new firewall, and pull them across one at a time, which is possible with routes, but you could be much more precise than that.
Yeah.
Seems to me you could do the same thing with this by writing the policies and just pushing them out. It's not OpenFlow, but that doesn't matter.
And so I actually love that you said this isn't OpenFlow because it is under the covers, but that's not even a relevant feature for our customers.
Aaron, you.
No, and so honestly, this is something where whether something is OpenFlow or not, like
who cares?
Who cares? Exactly. Like, do you care whether your networking software is written in C or C++? No. Right. That's just not a customer-facing relevant thing. And so whether the implementation is under OpenFlow or not, who cares?
So I just want to understand how granular I can get with what traffic we send through the firewall, because I like the idea of, okay, we've got new firewalls we're going to start migrating over, so I could just hang a new firewall off of there, and then depending on how granular I can get, I can control what traffic goes through it, because statefulness I would have to keep
in the firewall.
In the firewall, right?
And so it's exactly, and this is where, so people look at this and they're like, how is this big monitoring fabric? Because it's totally different, it's totally weird.
Yeah, I was going to ask.
But it's actually, it's the same, think of this like a circuit that you're building, but it's a bidirectional circuit. So in the original out-of-band case, it's a unidirectional circuit, and this way it's bidirectional. But to your question about how granular can you be, it's the same set of granular policies. You can match on L2 fields, you can match on L3 fields, you can do that crazy DPM thing that I was talking about. You can also load balance. So say maybe instead of a pair of firewalls, which would be traditional over here, maybe you have more traffic than that, or maybe you have like the older generation and the newer generation firewalls. You can actually spread across those.
Yeah.
My money says within 12 months, marketing has rebranded this as Big Chain Fabric.
That was actually the original internal name for it. Although my vote's for Big Security Fabric. So
Yeah, it's...
This is something I talked about 3 or 4 years ago. It's almost service chaining, but the DMZ is a very unique instance where what you actually want to do is just say anything from here goes to here.
yeah.
And the flow-based nature of your product is right there. And DMZs, there's just so much operational complexity in there that could be smoothed out.
Well, and think of like in my mind, in this world, this is where people do crazy things with policy-based routes. And what you have with lots of policy-based routes is a human trying to go, well, if this packet goes here and goes through this router, then I need this policy-based route here, but I need to make sure the next hop router has a matching set of policy-based routes to actually connect to the circuit. And what you really want is some sort of central intelligence to say, let me build these circuits. Now you're building the circuits with policy-based routes. And it's not doing TTL decrement, it's just doing like blind packet forwarding. But
It's much worse than that. It's not just policy-based routing, but PV LANs.
Yep.
And also separate switches. So you actually have to go to the data center and run a cable, but you're only allowed to go to the data center once a month.
And in some places you need to take a plane trip to get there.
Yeah, et cetera, et cetera. And it's just enormously complex.
Now before the use case, it was one direction, right? Take the traffic coming through, ship it over to the tool, we're done.
And it was not the production traffic, it was some copy of it.
It was a copy of it. So is this as easy as saying, since it's now bidirectional, is it handle traffic from here to here, and by the way, the return traffic does the same thing? Is that easy?
Yes, yeah. And actually, so assuming the wireless network works, I will show you a demo of exactly how easy it is. In case it doesn't, the overview is drag and drop. Basically, you define these are my services. You actually have like a little line that looks like a chain so you can visualize exactly what's going on. And then you define the subset of traffic basically on the classifier that goes through that line. And in case anybody's worried about bidirectional, you can actually make it a single directional as well, unidirectional as well.
Cool.
So I think we covered most of these. So the idea is actually to have a single pane of glass that manages a collection of switches. So in a typical deployment, you have at least 2 switches because in case one goes down. You have a pair of redundant controllers. You can scale this out. You can also do mirroring off of this. So if you actually wanted to monitor this totally independently, it works as a tap. We have some interesting tool health checks. So the idea is, which firewall has gone down? How do I do failover? How do I pull one of these out of the active pool? symmetric hashing and asymmetric hashing. So the idea is most firewalls or like an intrusion detection system, the traffic from A to B, if they're seeing that traffic, they also want to see the traffic from B to A. And so we have to do some interesting programming on our side to make sure that in a load balance scenario, that's actually what happens. You can think of it as a complex problem, or you can think of it as really easy because we've solved it for you.
Right. So with that, you could load balance multiple sets of firewalls in parallel based on consistent hashing in both directions.
Exactly.
Which we've tried doing in one place where I was at with ECMP, and it's messy as all get out.
It's messy when you start abusing the tools that aren't meant for that at a software
What are you
level.
trying to say? Yes, I agree. Which is why I like having something more deterministic than that. So, very sweet.
So would it be out of line then? I mean, I'm thinking if I'm
Is
going
that
to
a
be...
pun?
Yes, it was.
See what you did there.
But if you're going to do this right, so the problem is there are so many things that want to get data like this, and we end up doing it in different ways, like WCCP or PBR or something. Would it be out of line not only to do it for this, but if there was a WAN accelerator or something that could just go on?
Just one more service that you hang off of this thing. And what's great is these are actually lots and lots of ports, right? Like typically you get like 48 ports off of something like this.
Yeah. So you could just put all of your stuff on the switch and call it a day.
Yeah.
And then lastly, you'll probably talk about this more, but my only concern with this is the tool health stuff, because if we have a bunch of security appliances in there and all of a sudden the latency goes up because one of those tools is not performing well, then the network gets blamed, right? And we don't have very good visibility to prove that it's not us. So is there some kind of probe that does latency checks to say, hey, if we get over 50 milliseconds going through this tool port, let's pull that out or something?
So I believe, and somebody nod if this is correct, we actually have you can drop in a script to do this check now. Is that correct? Yes, okay.
Cool.
So you can drop in it. So right now, there's a naive health check, which is there a link? We've added some more intelligent health checks, but we also have a customizable point to drop in a script. So typically you would do is actually have some sort of application call from the controller to that thing saying, hey, firewall, are you responding at a reasonable rate?
Yeah, okay.
We've offloaded it to the switch.
Yeah.
I do have a question about this. Is this all managed by the same set of controllers? So is your monitoring fabric both out of band and inline? Do they coordinate efforts, or is this like one entity versus another?
You have stolen my next line. Much appreciated. So the idea is
But it segues.
the same pair of controllers can manage the out-of-band monitoring network as well as the in-band set of switches. Now, I will say a given switch can only be in one mode or the other. And that's, there are technical reasons for that, but it actually makes sense operationally as well. You don't want a switch that's taking span traffic to potentially send traffic back into the production network. I've tried that. It doesn't work very well.
So a leaf of your network is either inline or
Out of band.
out of band taking span. Okay.
Yeah. And good news, these switches are cheap, so it kind of doesn't matter.
So your enhanced filtering, and I can't remember what DPM stands for, but...
Deep packet match. That's the offset match thing.
Okay, so now is that the stuff that was being done by the appliance, the reg
That's
X
independent of that. This is actually a
Because you've got me
hardware
excited
chip.
now, and I'm now thinking, how can we use this appliance to get really interesting and say, okay, stuff that goes to particular sites gets pushed through IDS, IDP, that kind of thing, but other
Hold
sites
that
it
thought.
doesn't. Okay, so
So you are wise, hold that thought. So how are customers using this? So one of the biggest companies in the world is using this in a really interesting way. So they have a bunch of completely different security contexts that traditionally they would actually have as completely separate networks. So basically per site, they would actually have a per security context set of tools. So for security context A, they'd have one instance of SourceFire. For security context B, they'd have another instance of SourceFire, and again for security context C. With this, they're actually able to reuse the same tool across security contexts by using what basically on egress we tag with a VLAN that marks the security context. On ingress to the tool, they know, okay, this is VLAN 1, it's security context A. If it's VLAN 2, it's security context B. And like the total amount of traffic going through this allows this to happen, but they actually have hard isolation from a policy level for what traffic goes to where. And so, and also they have different policies. So they have a different set of tools that depending on the context that these things are required to go through. Does this make sense? particularly since from a data center switch standpoint, this is where the lots of ports becomes useful as well.
What about packet duplication? I've had instances where people want to feed the same, unless that's what you're doing here, feed the same data stream to SourceFire and FireEye at the same time.
So you can do that. It looks more like a mirror port. Generally speaking, at least from a user intuitive level, in the old world, you would have a physical sequence of wires, and that's what we've tried to replicate because I think that's what people understand better. I'm pretty sure that you can actually break it and so with a mirror port, send to both.
Yep. Because one of the things I've done somewhere, we can't say where, is actually capture a stream, but send it to 3 different devices. And each one, so it might be like an IDS, and another one is a logging forensic recording engine, and the other one is a different type of IDS, a prevention system or a malware scanner or whatever you like. And the same one stream, but sent to 3 different destinations. And so we had to do packet duplication in there.
And so that's almost more of a case for the out-of-band one. That's where we had the multicast thing that I was talking about.
Yeah.
But we can do this in band as well. The only thing is, I believe only one of them can be in band, because think of it as when they're in band, a tool can actually elect to not forward the packet.
Yep.
So you 2 of them end up being out of band in that case.
That is a valid security case.
Yeah.
It's quite popular with a certain.
Yeah.
Yeah, and there are products that can do that exact
Show me the
feature.
packet as it really was, not as somebody could have mucked with it.
No, I need to have that packet replicated 3 times or 5 times for 5 different security appliances.
Yeah. But the idea is, after you go out to those 5 security different appliances, you can't have all 5 of them sending back the copy of the packet.
Oh, no, they don't need to send it back.
And that's what I'm talking about. That's now the out-of-band case.
All right, yeah.
Even though it's hanging off of the same switch.
Okay, right. I see.
Is the inline version coming with limitations, or can you still monitor as many ports as you want?
You can still monitor as many ports as you want.
Oh, cool.
I mean, I'm assuming I'm understanding your question correctly, but yeah. I mean, we do full line rate across all the ports, I think is what you're asking.
Okay, so there are no limitations because you are carrying the production traffic as well at the same time, yeah?
And this really comes back down to what the Broadcom chips are capable of. So you can take a single packet in and mirror it out all other ports at the same time at line rate, if you wanted to do that. Completely different use case, and this is what John was talking about. Who here's heard of Science DMZ? Anybody work in an academic network? All right, so Science DMZ is this strange but very interesting problem that affects a bunch of academics. So imagine that you are a researcher who's trying to consume data from the CERN Super Collider, and it's terabytes and terabytes of data. You go to download a file, and you've got a 100 gig network, and it's dedicated for this purpose. And you find that putting a single 100 gigabit stream through your firewall, you get 3 gigabits of performance through it. And that's because inside the firewall, there's all this parallel processing that expects to actually, if it can support 100 gig, it's not 100 gig of a single flow, it's across lots and lots of other flows. But the per flow rate is actually kind of low. So what happens is, through a tool, you can say, you know what? Send all the traffic through the firewall except for this one flow, which is going to be my really long-lived flow. So I'm whitelisting flows from going through the security network. Interestingly, we've actually started to partner with companies, we're at least starting, I should say, started is the wrong tense, to partner with companies that provide these tools that make this happen automatically. So if you imagine flow comes in, downloading traffic through one of these tools, this tool actually logs to a well-known logging server. That logging server is configured to actually make the call into our controller that says, hey, I know what the 5 tuple is that's actually allowed to be whitelisted. Let me make that REST API call, the one we were talking about earlier, to whitelist this automatically. And then the traffic now goes direct without going through the firewall, removing that bottleneck. What?
No NAT?
I mean, optionally if you want an NAT to, but not pictured in this example.
Yeah.
You brought up I never heard the term Science DMZ, so that's really interesting to me. I work in an academic environment,
We have a lot of very sensitive data, modeling clusters that research and development people are getting to. And I've always heard from the requests from our CISO and from the scientists working on campus the exact opposite. It's the most sensitive data on campus, bottleneck it all, and then it's a culture thing.
So I guess the question is, what's the source of the data? So if you take like a certain super collider thing, that's completely public data. So they don't mind if the entire world gets it. It's just an efficiency problem to do that.
I see what you mean then. Yeah. Okay.
Yeah. By the way, happy to chat with you afterwards. There's lots of people who'd be interested in talking to you about where to use this use case.